All right, let's do our last one, sodium acetate. So sodium acetate is normally written CH3COONA. The reason that it's written that way is because the sodium has taken the place of where a hydrogen could have been. Even though we name the metal first, the metal's normally put on the right-hand side. But don't be thrown by that. This is indeed sodium acetate, or sodium ethanoate. It's an ionic compound, and so we need to learn to see that, oh yes, there's sodium ions that are attracted to the negative anion of the acetate. So if I put this salt in water, the question is, what will it do to pH? Well, let's put it in some water, and we'll form liquid, or aqueous rather, sodium acetate. So here it is, CH3COO. That's going to ionize into acetate, and this is going to ionize into sodium ions. Now we know that sodium as an alkali metal has no further reaction with water. We're not interested in it. But this guy is very interesting to us. This is the conjugate base of the weak acid, acetic acid, which means if these molecules are in the presence of water, some of them will take back hydrogen and leave behind OH. So immediately you can see that the salt, sodium acetate, is going to lower pH because so it's going to raise pH because this water molecule will donate a hydrogen and leave behind OH. So let's see that happen. CH3COO- in the presence of water will, in large part, form CH3COOH and leave behind OH. Again, don't be confused. This can only be called an acid if it ends up donating the hydrogen. It got its hydrogen from water because it's so weak. Therefore, water, if you like, has donated the hydrogen. It's acted as an acid, and this has acted as the base that's accepted that proton. Because hydrogens are bound up in this molecule and not free, they cannot lower the pH by forming hydronium. Instead, the water molecule in the presence of the conjugate base of the weak acetate ion has given the hydrogen to acetate. It's formed acetic acid, but this has locked that hydrogen up and it's not free to donate it anymore, and therefore OH has been left behind. The concentration of OH is significant, which means pH rises, and we would say that this is a basic salt. What's the basic salt? The starting salt of sodium acetate.